Section 1-1 is entitled Expressions and Formulas. Let's start with a couple vocabulary terms that you may already be aware of. The term variable. Variables are letters that represent unknown quantities. So these would be letters like X, Y, Z. An algebraic expression is an expression that contains at least one variable. So an algebraic expression is going to have numbers, variables, and operators. So an example of one might be something like 3x plus 5. The order of operations. This is a predetermined order in which expressions are evaluated. In other words, in what order do we do all of the different operations within an expression? And it's important that we all decide to do it the same way, because if you do things in a different order, you might end up with a different answer, and we all want to get the same answer in the end. So the first thing you need to do is deal with any grouping symbols that you have. Parentheses, brackets, braces, a fraction bar. Also in this category would be absolute value bars and square root signs. And so you want to evaluate what's within those grouping symbols first. Second thing you need to do is evaluate any powers. That is, deal with any exponents that you have. Thirdly, multiplication and division, and we're going to do both of these operations together from left to right. What that means is if a division comes before a multiplication, I need to do that first. Just because I'm saying multiplication and then division does not mean I do all the multiplications first. I do them as they come in order from left to right. And then addition and subtraction together from left to right. The same idea, all of the additions and subtractions as they come in the expression. So let's take a look at a few examples here. I'm going to evaluate each expression if m is equal to 12 and q is equal to -1. So my first step is to plug in 12 for m and -1 for q. So that's going to give me 12 plus 3 minus a -1 squared. Now, order of operations says I deal with what's inside the parentheses first. Inside the parentheses I have 3 minus a -1. Remember that minus a -1 is the same thing as adding a positive. So that's going to give me 12 plus 4 squared. Now I have an addition and a power and exponent I need to deal with. So that's going to be 12 plus 4 squared is 16. And my final answer is 28. Second example, m divided by 2q plus 4. So let's go ahead and plug in 12 for m and -1 for q and add 4. Now I put the -1, I think I did this, might have done this in the problem above. No, I didn't. I put -1 in parentheses. Remember that parentheses can be grouping symbols, but they can also represent multiplication. And that's what's going on in this case. So I have 12 divided by 2 times -1 plus 4. I think your first response would probably be to do the 2 times -1 because that looks kind of easy and it's just kind of staring there looking at you. But order of operations says since I have division, multiplication, and addition, I do my multiplication and division in order as they come from left to right. So the first thing I have to do is 12 divided by 2, which gives me 6, and then multiply by a -1 and add 4. So doing the multiplication, my final answer is a -2. Next example. Let's evaluate this expression if x equals 5, y equals -2, and z equals -1. First step is to plug in values for x, y, and z. So I have 8 times 5 times -2 plus a -1 cubed all over -2 squared plus 5. If it's a particularly complex problem like this, I like to, before I start using order of operations, I like to go back and make sure that I did plug in everything correctly, and that looks pretty good. So, in this case, my fraction bar is a grouping symbol. So I need to evaluate everything on top, and then evaluate everything on bottom. On the bottom, do those separately, and then actually do the division that the fraction bar represents. So 8 times 5 times -2 is going to give me a -80 plus -1 cubed. -1 to the third power is a -1. And on the bottom, -2 squared is 4 plus 5. And continuing to evaluate the top and the bottom separately gives me a negative 81 over 9, or a negative 9 for my final answer. Here's another definition. A formula. A formula is a mathematical sentence that expresses the relationship between certain quantities. Remember, we used formulas quite a bit in the end of geometry last year. So here's an example. The formula for the area of a trapezoid is capital A equals 1/2 h times the quantity B1 plus B2. And you'll remember that the large A stands for the area, H stands for the height of the trapezoid, and B1 and B2 are the lengths of the bases. So we need to write an expression for the area of a trapezoid whose height is 4x inches and whose bases are 6x and 8x inches. I kind of like to just pull the information out. H is going to be 4x, and it doesn't really matter which one is B1 and B2, but one of them is 6x and the other is 8x. Now let's just plug those into the formula. So the area is 1/2 times the height, which is 4x, times the sum of the bases, which is 6x plus 8x. Now, using order of operations, I have multiplication here, but I have some addition in the parentheses. So I have 1/2 times 4x times 14x. And now that I have all multiplication, I have 2x times 14x, where the area is equal to 28x squared inches.